Have you had an electrician come round and he starts talking about your gas and water? And you think, hang on, I've only actually come round to put a light up, and you want to know where my gas meter is and where my water stopcock is. What's that got to do with my electrics? Something called main protected bonding. We're going to have a look at it now. Okay. There's a very good reason why the electrician wants to look at your gas and water supply when he comes to do some electrical work for you. It's because these services, your gas and water, run through your house in copper pipework. And copper pipework is very conductive of electricity. So the pipework goes off to your hob, goes off to your boiler. Your water pipes go off to all your taps, goes off to your immersion, and also goes off to your boiler. And these appliances are electric as well. They're connected back at your fuse board. Your immersion heater, that's got an electrical supply which goes back to your fuse board. And if there's a fault on this immersion, that fault could appear on your pipework going to your water, which is also connected to your tap, and you could be touching that. So it's important that your pipework is all connected together and bonded back to your fuse board to reduce the risk of the shock. We'll talk a bit more about that. So we have a situation here where there's the fault on the immersion heater. The live is touching the case of the immersion, which is also passed that fault onto the pipework, which will run down a couple of pipework to the tap, which you're touching, and that's going to give you an electric shock. That's obviously a very dangerous situation. But this situation could get even more dangerous. So we've got the situation where there's 230 volts applied on the copper pipework to the tap, and you're touching that, which is bad enough. But it can get worse because you could also be touching the oven at the same time. The oven is often very close to the sink, and you could be touching both appliances at the same time. Now this gas pipework is at 0 volts, there's no fault on that. So you've got the situation that you're in between something at 230 volts and something at 0 volts, which is perfect conditions for electrics to flow. That power is just going to flow right through your chest, right through your heart, and back onto the oven. And it can easily provide a very fatal electric shock. So that's what main bonding does. It limits the ability for you to get a potential difference where one pipework is at 230 volts and one pipework is at 0 volts. You tie it together, you bond it. It's called main equipotential bonding. You put a copper conductor on each pipe and you take it back to the consumer unit where it joins the main earthing system. What your electrician will need to do to make sure that you don't get any voltages, dangerous voltages, appearing on your gas, on your water pipes, appearing on your taps, appearing on your appliances, is bond everything together. So he'll put a clamp on the gas pipe and on the water pipe. He'll run a conductor from these pipework back to your main earthing terminal, your consumer unit, and everything is tied together. This is the central point where all your earths are connected. And so therefore, everything is joined together. Nothing can raise to a different potential. You can't get one piece of pipework at a greater voltage than another to give you the potential to get a shock. So that's what your main protective bonding does. It ties everything together. It gives you an equipotential zone where everything is going to be at the same voltage. There's no difference in voltage, so you can't get a shock. Okay, that was just a basic overview of main protective bonding. I hope you found it useful. I am working on another video which will go into a lot more detail about the protective bonding. So anyway, again, thanks for watching. If you did find it useful, I'd really appreciate if you could subscribe or just leave us a comment. It's always nice to know what you think. Anyway, thanks very much, and I'll see you soon. Bye.